Hey guys, so I'm just going to go through this question. First of all, what we can see here, I'm not going to read every question out, but what we can see here is we've been given the area of each side. So I would always start off by writing out what we know. So if we look at 2 root 2 there, well, that would be the area of this side, which we can call A, and that's going to be x multiplied by z. If we look at this side B, that's 8 root 6, and that's going to be y by z. And then finally, if we look at our side C, so that's 4 root 3, that's going to be x by y. Okay, so that's all we know at the minute. That's what we are looking for, or that's what we have. We are going to be looking for x by y by z, and that's going to be equal to the volume. So what I can see here is that if I multiply all these together, so xz, yz, and xy, well, multiplying all of those together will just simply give me x squared, y squared, z squared. And if I do that then, and I get 2 root 2 multiplied by 8 root 6 multiplied by 4 root 3, then whatever answer I get, I just have to root both sides. So that's just going to give me x squared, y squared, z squared is equal to 384. When I pop all that into a calculator, root both sides then just to get x, y, z, which is going to be our volume, and we are going to get 8 root 6 centimeters cubed. Okay, the next question. So the next question is going to use Pythagoras' rule. So if you look here, we can see actually they've written in everything on the diagram. Fabulous. What we can do though on that diagram is we can draw our right angle triangle. And that would be our right angle there. So in order to figure out the vertical height of the cup, they've told us, so we just have to verify that. So all we're going to do there is say that 9 squared is equal to 3.3 squared, just put that in brackets, plus I'm just going to call it the VH to be squared. When I go and solve those, I'm going to get VH squared is equal to 70.11. Now just remember, all I did there was I took this, brought it over the far side. I actually flipped them so that VH square is on this side. It doesn't matter, it'll still work. You can flip it at the end. I took this, brought it over this side and subtracted it. And then I'm just going to root both sides. You might see in the marking scheme it says H. Doesn't matter what you call that. I just put it as VH because it said vertical height. It does not matter. So my vertical height then is going to be 8.37 centimeters, which is what they asked for. Next part, find the curved surface area of the cup, correct 2 decimal places. So the curved surface area you will see in your log tables. It is on page 10, and where you see cone, you have A and V. Area refers to the surface area. Any 3D shape, it's going to refer to the surface area. Okay, so curved surface area then is A is equal to pi or L. Now our L is going to be this thing here, the slant height. So, and they've asked for 2 decimal places. So I would use your pi function on your calculator here. So A is equal to pi, replace R with 3.3, and my height is 9, and that's going to give me, just put an equals down here, 3 by 9 is going to give me 29 pi, and I'm just going to use the pi function on my calculator, and that's going to give me to 2 decimal places. So it's going to give me 93.305, so that's going to be 93.31 centimeters squared. Okay, so for this question, first of all, it says a couple of hints here on this. So if we look at it, asks for this is the net of the cup, which if you look in your log tables, there's a very similar to kind of diagram that looks like this, and it is the arc or sector on page 9. So we're going to use that. The first thing you will note on page 9 is that it gives you a formula for length and area in when your theta, that's this guy here, is in radians and is in degrees, and you can see here that we are going to be looking for it in degrees. So we're going to use the formula for degrees. So with this question, I'm a big fan for using stuff that we've already used just beforehand. So you'll see here we use the area, we found the area, the curved surface area of the cup. Now, the curved surface area of that cone, like that's the net of the cup. So we've already found that curved surface area, and we could let that equal to the area of the sector, which is in degrees, the formula. Area is equal to, let me just get up my log tables. So it is pi r squared theta over 360 degrees. And we've already found area up here of the curved surface area of the cup. So those two should be equal. So if we let them equal then, so if we see what we have up here, we got 29 pi. I'm just going to work with the pi's for a second, is equal to, and we're going to fill in this formula that we have here. So that is pi r squared. Now r in this case is 9 centimeters. Again, if you look at the description or the little diagram that is on page 9 of your log tables, you'll see that that says r there. So that's going to be 9 squared theta over 360. And then these two will cancel, and I'm going to have 29 divided by 81 is equal to theta over 360. Now, when I get that, and obviously I multiply both sides by 360, what I'm going to get is that theta is equal to 132 degrees. Now, I know that's different to how the marking scheme did it, but I think that's way better because you're using something that you've already just found. Okay, so the next part then, this may have been a little bit, first of all, I'm not even going to read any of that. I have a lovely diagram here. You have already read it, so I'm not going to waste your time. Looking at that diagram, remember what we used in the very first part. We talked about Pythagoras theorem, and what we were looking at there was using triangles. So again, I think we're going to use triangles here. This is not, yeah, this is the same cup, but if we just look at triangles here, what you're going to get is that the triangle that we had at the very beginning looked like this, 3.3, and then this was 8.37, and I know we had a slant height of 9 in that case. The new triangle that we're going to be looking at, which is this smaller one, well, they've told us that that's 7.37. We don't know the radius because radius is going to be shorter, and we don't know this side here either. However, what we do know is that we have two things that are going to be the same. So we have this angle and this angle is going to be the same. We have that this angle and this angle are going to be the same, because again, if you look here and here, what's that? Well, that's alternate angles. Sorry, not alternate, corresponding. And then we know that these two are going to be the same because they're right angles. So what we have is angle, angle, angle. So we actually have similar triangles there. So what we can use then is the ratios. So we know that 3.3 over 8.37 should be equal to the same ratio as r, the radius, the new radius, over 7.37. And then we can just simply solve for r, and you're going to get 2.905 centimeters. And then because we're going to find volume, we're just going to use the volume formula. V is equal to 1/3 pi 2.905 squared multiplied by 7.37, which is my height, and then that's going to give me a volume of 65.16, and they said one decimal place, so that's 2 centimeters cubed. So again, here's a question very, very like our questions for homework yesterday, or for the the Christmas period. So water flows into one of these cups through a cylindrical pipe of radius 0.8 centimeters at a flow rate of 2.5 centimeters per second. Find to the nearest second how long it will take to fill the cup to the line at F. So the first thing we're going to have to figure out is our cylinder. So our cylinder, again, if you want to draw a little diagram, so we know that the radius of this cylinder is 0.8 centimeters, and then we know that the height must be 2.5. So first of all, find the volume of a cylinder, which is pi r squared h, and that's going to give me pi by 0.8 to be squared multiplied by 2.5, and then that's going to give me 5.0265 centimeters cubed, and that's per second. That's how much water is entering. So again, then using our distance or volume, speed and time, we are looking for time, so we're going to use our distance or volume, which is so our distance or volume of the total cone, so that's from the previous answer, 65.2 centimeters, and we are going to divide that by 5 points. So this is the speed, 5.0265, and that's going to give me 13 seconds. Cm cubed. Okay, the next one. The company decides to change the position of line F in order to limit the capacity of the cup. Okay, so just reading this one, I know when you read it first, you kind of say to yourself, well, they've not really given us enough information, which they haven't. And when we don't have enough information, chances are we're going to end up using algebra to try and solve this. But first of all, what I would write down is my volume formula. So your volume is 1/3 pi r squared h, and they're telling us that that's going to be limited to 60. Okay, so remember two triangles that we had earlier. So the one that we knew, I won't draw too small now, so the one that we knew was 3.3, 8.37, and then I think this was 9. Now we have a new triangle, so we had another triangle that we knew of as well. I'll just draw this new triangle. Is obviously going to be a little bit smaller. We won't know the radius, we won't know the height, we don't need to know the slant height in this case, because all we want to know in this is what your R and your H are. But what we will know is that they're going to be in the same ratio as what we had before. So what we're going to have this time is we're going to have R over H is equal to 3.3 over 8.37. And that's going to be really helpful, because what we can do is we can write one of the variables. So let's just go with, we're going to want the H, are we? Yeah, well, we're not, we're going to want the H more so than the R. So what we're going to do is we want to replace, what I'm looking at here, sorry, my thought process, I want to replace this R in my formula, because I'm going to want to find out what H is, so that I can then take it away from 8.37 to figure out what my X is going to be. So I'm going to put that in terms of H, so that's going to give me R is equal to 3.3 H. That's just multiplying both sides by H all over 8.37. Now this is going to get a small bit messy, but just stick with me. Okay, so sorry, I just moved some bits around there because remember we need to try and stay inside of this box in order for your exam to be corrected. So we are going to now replace r in that formula. So what we're going to get is 1/3 pi. Now instead of r, I'm going to put in 3.3h all over 8.37 to be squared. That's going to be h, and then equal to 60. Now I would go ahead and just simplify that. Don't get rid of pi's or anything like that. Just simplify the square part first. So I'm going to get 1/3 pi. Now 3.3h to be squared is going to give me 10.89h squared all over 8.37 squared. That's going to give me 70.0569. And I'm just putting that in brackets for the moment, just for a second, is equal to 60. Let me just make that a bit smaller. Okay, multiplying that out then, I'm going to get pi by 10.89h cubed, and then my bottom is going to be 3 by 70.05969. So let me just pop that into my calculator here. So multiply that by 3, I'm going to get 210.1707, and that's all going to be equal to 60. Okay, multiplying both sides, then I get 10. My pi goes here, I'm just going to shove it there at the beginning. 10.89h cubed, and when I multiply 60 by 210.1707, I get 12,610.242. And then I want to divide both sides by pi 10.89 to get h cubed. So I'm going to get h cubed is equal to 12,610.242 all over 10.89 pi. Now I'm going to cube root both sides in order to figure out what h is. So I'm doing that at this point just because I want to put all of that into a calculator. So I'm going to get h is equal to, when I cube root that, I'm going to get 7.169. Now just remember that h refers to this height here. We want to find x. So for the last part of this, what I'm going to need to do is I'm going to need to take, for x, I'm going to need to get 8.37 minus 7.169 to get what x actually is, which is going to be 1.2, and that's centimeters.